Hello everyone. Today in the lecture, I want to explain about the pointer to pointer. Normally, what the pointer can able to do? Pointer store the address of a variable of the same type. If any variable is declared in the integer type, then a pointer also should be an integer type. Then this pointer can able to store the address of the same type of variable. So that this is a thing we have discussed several times in previous lectures. Now, what is today topic? Pointer to pointer. Now there we are declaring one more pointer. That pointer should be declared in this format. Two indirection operators. It is a compositive operation to perform the double pointer or pointer to pointer operation. Okay, so now, so that pointer variable is the P1. For this P1, we can able to allocate a address. So now how we are allocating the address? Now the pointer P1 is equal to address of which address we want to store? We want to store the address of pointer variable. P is a pointer variable. Now, what could be happen here? Whenever pointers store the all pointers are store addresses only, they cannot store any value. Here what happened? A P stored the address of A, then P1 stored the address of P. So this is a scenario we are discussing in the today class. Now let me elaborate the same discussion with some diagram process. Now there is after you declare a variable, the variable name is that is A, and it occupies the 4 byte of memory, and every variable has their own base address. Base address nothing but is the starting address of a particular variable. Now here there is a one more variable, that is a pointer variable. Now pointer variable also integer type. This pointer variable itself it has their own base address. Let us consider the base address is a 3000. Now, but what is the statement? We are allocating the address of A at P. So now this pointer is pointing to the which location? It's referring to the location A. Now what we could say? This is a memory. It's named as A. Can operate with A. Also can operate and control with P. So two variables are controlling or accessing the data and modifying the data on same memory. One is variable name itself, one more is a pointer variable. Now what could be happen? I could say a one memory control with the two variables. One is a pointer variable, one more is a variable name itself. So like that we are controlling. Now whenever you increment the A, that you can able to write A plus plus, where we are incrementing if the value of A is equal to something like a 5, then what is the answer for this statement? The statement answer will become a 6. Nothing but the value will be modified as a 6. Now there is no 5. Already it is modified as a 6. Now similarly, if you apply the same operation with pointer P plus plus, what would be happen? It means that it is also increment on same memory. No, it is also increment on same memory. So the memory is here itself. This memory will get affected, not the pointer memory. It's effect on this memory only. Then the value is become 7. After this, the value will become 7. Now we are operating on a single memory with two variables. One is a variable itself, one more is a pointer variable. So this is called as a pointer operation. Next, but now we giving a authority on the same memory with a one more variable by using the pointer to pointer concept. See, it's very complex. It is very unfortunate to control one memory with the two variables. But by using this concept, we are allocating a one more third party that is also controlling on same memory, controls the same memory. So what could be happen? There is a one more alternate variable. One more variable is a pointer to pointer variable. The pointer to pointer always pointing to the only the pointer variable. Means it cannot store the, I cannot allocate the address of something like a normal variable, because that variable is designed to store the address of only the pointer variable of the same data type. Okay. Now let us consider their base address is a fourth one, is a common base address. Now what is the variable name? Variable name is the P1. Now P1 store the address of which address it as it is storing? It is store the address of pointer variable, direct pointer variable. Now it is a pointer to pointer variable. It is stored the address of the pointer variable. Now what could be happen when I apply something changes on if I perform the pointer to pointer P1, and if you apply the plus plus, where actually the operations will be applied and where changes could be applied. It is also apply changes on pointer to this memory, and this memory pointing to the again the variable memory. So here only the effect can be created. Here only the effect will be created, not on P. first pointer, it is pointing to this address, which take the reference of this value, and again it move to this direct memory and apply the changes at 8 cells. 8. So now how many variables are controlling this memory or access the memory, read the memory? Direct pointer and pointer to pointer also. Pointer to pointer also. So this is a basic scenario behind the pointer to pointer. This concept also called as a double pointer. Also called as a double pointer. Okay, sometimes it is a pointer to pointer, sometimes it is a double pointer. The name can be different, but the scenario is similar. Same concept. Now I want to explain this program. Already, I think I explained up to here. I already explained up to here. Now, whenever you want to print, and this one also I think I have completed. I want to print something like a here. I want to perform the printf operation. Print whenever you print percentile D comma A. So what is the output? If the value after the last modified value is a 8, na, then your last modified value is a 8. Will be print according to our example analysis. The value will become 8 only. So similarly, whenever you come to the next statement is I want to print the same thing by using pointer p. So obviously the value is become 8 itself. Similarly, if you print the same thing with pointer to pointer, the output is same. Again, it is 8 only, where they all variables are operating on 2000 base address. Now P operating on this memory, and also P1 also operating on this memory. All these three variables are controlling or read, access the value or modify the value at the same memory. The address or the memory is a base address is at 2000. So this is the first fundamental concept about pointer to the pointer that can able to process with function. This concept can able to process with a arrays. Okay. Let me show the next example on pointer to pointer concept. Pointer, it may be a function call. Okay, I will explain now. Function call with parameter passing. Let me keep this concept. Let me keep this. Okay, so let me now see in this concept. So here I am on to using call by reference and pointer to pointer both. First, I want to create a main program. Program is the function main function, and I'm declaring one variable that is an integer type, something like int a, and also I'm declaring a one pointer p. Two variables I'm declared. Now that p is equals to address of I'm explaining with a very simple example, and I think you understand up to here. Next, I want to pass modify function with parameter as a address of pointer. It is not a address of variable, it is a address of pointer. Something we are passing from this function, that is a one parameter. This parameter is called as a reference parameter. It is a reference. How do you know that it is a reference? If the value is normally if you pass a, then it is called as a call by value. Something call by value. If the a is equal to 10, example, if the a is equal to 10, then indirectly it is in that we are passing a 10 value from this location. We are passing modify is become it is passing a value as a 10. But what we are passing now, it is not a 10 value we are passing, not a variable name we are passing. We are passing a parameter that's a reference parameter. It is a reference, but it is a address of a variable. We are passing address of p. Somewhere, if we through our transfer are passing a parameter as a address, that formal parameters should be a pointer variable, because nobody can store the address like a normal address in any one of normal variable. Addresses can only store or accommodate with pointers only. So now I am calling this function with this parameter. Now here there is a one function definition of modify who can able to catch this corresponding address. Address can able to catch by only accessed by only a pointer formal parameter. But what is this address? This is a address of already a pointer. This is the address of already a pointer. So now here to address of a pointer can only stored by the pointer to pointer or double pointer variable, not by a normal variable. Okay. So means it should be it should be like a pointer to pointer normal variable. We had to create a variable or a formal parameter should be a pointer to pointer because you are passing not a not normal address. It is a address of a pointer, so that receiver formal parameter should be a pointer to pointer variable. So now we have created now the next one. Only one parameter we are passing. So what is the value of a 10? What is the value of a 10? Okay. The next, I'm writing the definition. Here I want to modify the value. Here I want to modify the value. So that value is become something like you can do anything, any kind of operation. Now I'm writing like pointer to pointer p1 is equals to p1 is equals to. So what is the value of a 10? Now I want to change the value as a something like a 95. 95. Okay, as if I want to modify the value, so I close this one. Now it's a very simple program. I write this program with only write this program with a very few number of lines. And then I just want to printf percentile d comma a. You can able to print, or else it's maybe you can able to print with pointer variable. So pointer p. So because this is these two are local variables of a main. Whenever you print this one, what is the output we have to verify? So that is a very important point. So see what we are doing. Void modify is a one function call from the main function. Their parameter is a address of a one more pointer. Who can able to catch the address of a one more pointer? Pointer to pointer variable only can able to access that address. So obviously we will access the value. Now what does that mean? Now pointer to pointer enable to access the value of the corresponding A. If the value of A is 10, already we practiced this example with the different values, but in that example, we taken a value as a 10. So now I'm writing here 10. Now 10 can able to access by how many variables? Here pointer variable can able to access. Pointer variable can able to directly can able to access because that notation already we wrote in the main function. But this time what happened? We are passing a parameter. This parameter is forwarding the address of the pointer. Now, what is the address of the pointer? Normal pointer address. It is a 3000. Now, 3000 we are passing, but pointer to pointer, what it is going to be do? It is able to access based on the first pointer address. It can able to access the corresponding variable memory. Now, it can able to access the reference of this address. Pointer can able to access the normal variable memory. Now, what is the value of this normal variable? It is not 10. Now, 10 could be modified as 10 could be modified as 95. 95 modified. It's modified. Where you have done the modification? You have done the modification here. Now see, we are not even the return the value. So this is the thing I have explained in the previous pointer concept. No need to return the value any from the calling function. Pointers will apply the changes in the corresponding variable, not from the point P1. We are not accessing the value. We are accessing the value after we modify at A. So whenever you are processing this, already they made a changes with your reference variable. Your variable value has been changed. No need to return anything. Nothing but I could see there is every time I explain the students that there is a one black magic is going on by a particular person. It's a simple example to understand the student. Okay, actual real person is here. And real real person nothing but is a real entity or object. It is a real entity or object. It is our normal variable. So it is a variable A. Now, so there is one object. The black magic is performing by a particular person. Don't take it as a serious. It is a general example. Now, I am hitting on this object at the head part. Now, this person will get pain at the head, get the pain at their head. So whenever he hit at the corresponding neck place of this object, now he will get a pain at the neck place. Like that, actually, we are performing operation on this object. The reflections are created on real entity. Similarly, whenever you create any changes from the pointer, that reflections are actually performed on A. But this time what happened? It's a pointer to pointer. Now there is one more object also there. From this object, when I apply some changes, the changes are reflected from this object to this object. So like that is a general example to make you understand, because we are watching so many movies and that kind of scenario. Oh, these are some scenes are have that kind of things, so that to make you understand well, I can get this example. So pointers and the real entity is here, but we are applying the changes or any modification from other supporting variables. They are generally pointers. Okay, this is about the pointer to pointer. The next concept is about, I think this is the best example to understand about how the pointer to pointer is operating, how we can able to perform the function call in the pointer to pointer concept. The next concept is about array of pointers. It's a very important concept, array of pointers. Now, sometime we need a more number of pointers. Let me explain the array of. Already we had a practice with uh, but there I didn't specify that that is the array of pointer. I just explain about the notation format. But thing is that I just recall the same concept. If you need a, if there is one program, there are multiple variables are there, A, B, C, D, so many variables are there. For all the variables you want to create a something like a, for all the variables you want to create a pointer variables. How many pointer variables you need? I need a pointer variables for all the five variables. Now, five pointer variables I need. For normally, what I should do, I should declare the P1 pointer P1. I should declare as a pointer P1, comma, pointer P2, comma, pointer P3. Like that, we have declared the multiple number of pointers. It's actually very complex to remember the names, complex to write in the code. Not so easy. So what we are doing now, we want to find out the alternate procedure. What is the alternate procedure? The alternate procedure is a declare one a array that is a pointer array. How many pointer elements you need? You need a five element. Now I just want to give a title for this topic. Array of pointers. Array of pointers. Okay. So now actually what is the major need of a array? Whenever you, instead of declaring the multiple number of variables, we can use one of the major point benefit from the array. Instead of declaring the multiple variables, when you declare an array will also separate the element with the indexes. So that thing we already discussed. Now this time I'm declaring a one pointer with multiple elements. Now all elements are work like a pointer only. Now there is a one pointer is created. I will explain with example. First thing is that here there is a array is created. But what is the type of this array? This array is a pointer array. Now how many elements are there in this array? There are, how many elements are there? There we have a five number of elements. Element number 1, 2, 3, 4, 5. Five elements are there. All five elements are work like a pointers only. So now this is the 0 index, this is the 1 index, then it's the 2 index, 3 index, 4 index. All they are not a normal variable. They are a pointer variable. Next it is a 4 and 5. 4 and 5. Okay. Now whenever you call this value, this is called as a some zero indexed element, and it is a pointer. It is a pointer variable. Next one is a, there is a one more pointer name is called as a p of 1. There is a one more pointer is called as a p of 2. Like that, every element is not a value; they are pointers. Now this is the element called the pointer 2 like that. Okay. Now let us consider there are some, how many variables we have? We have a five variables. Now I am declaring a five variables. Now one is A, B, C like that. Okay. So B, C like that. We have a five variables. Now the variables are, we want to assign now P pointer, P of 0, P of 0. Or that variable, this element is stored the address of, stored the address of A. Address of A. What's going to be happen now? Now this is a pointer element stored the address of A. Now pointer P of 0 is, it has been stored the address of A. It is a reference for variable A. Now the next one is there. Next one P of 1. It is a pointer element. It stores the address of B. Next one, there is a pointer variable 2. Pointer variable element 3. 2 will store the address of C like that. Now here I am allocating for 3. Next one 4 will let's allocate. Last one is the keep empty. P of 3 store the address of, it's the address of D. Four elements are there. These four elements are pointers, and then they store the different integer variables. Now let us consider this is A, this is B, this is C. This is a different kind of concept. It's benefited whenever we have a multiple number of pointers are needed, that time we can able to use this concept. Now what could be happen? Pointer one is pointing to this location. Pointer two is pointing to this location. This is pointing to this location. This is pointing to this location. Their addresses are example. A base address is a 2000. Now 2000 stored over here. Now next one is let us consider this is a 3000. 3000 stored here. The next C1 is a 3500. Yes, 3500 stored here. Next one is a 3700. Yes, 3000 stored here. Like that, these addresses are stored and they are become. So this is a 3000. Let me write everything because you can understand whenever, if you understand the diagram, you can understand very easily the concept. 3500 address. This is the next one. Next variable address is a 3700. 700 like that. Okay. These are the base addresses of each variable and they were stored in the pointer array. Now if you print something like a print f of a, if the a value is equals to 5, b value is equals to 6, like that, let us consider. If you are printing something like a pointer percentile d, comma pointer p of 1. We have 1. Whenever we print, so what is the value will be print? It's the value of, which will print the value of one index. What is the one index value? In case the value is equal to something like a 7. Now 7 will get print here. Now 7 will get printed. I am not applying the value for their variable, but you imagine that if the value is a 7, obviously the output is become a 7. Whenever you apply the changes over there, whenever you apply changes like mm, whenever you apply changes like printf percentile d comma pointer uh, p of 1 plus I am performing. Then what could be happened? Which is increment the value and the result is become a 8 like that. So which is about the array of pointer. The next video I will explain array of pointer with the strings and arrays. That will become a very big topic. So that I will explain in the separate topic. Okay.